So today we'll move on to our next experiment, experiment number 7. So it is 4-bit R to R digital to analog converter. So we are giving the input as digital input and we are going to convert into an analog output. So the aim of our experiment is to design a 4-bit op-amp digital to analog converter using 4-bit binary inputs from toggle switches. So here we are using a 4-bit digital input. So digital inputs are D3, D2, D1 and D0. So these are my 4-bit digital inputs. I need to convert that one to analog output. So R to R is one of the types of DAC converter. So in DAC converter, R to R is an resistor ladder. So it is an electrical circuit made up of repetitive units of resistors. So here you can see R, resistor R and 2R. So this R to R, there is a combination of ladder circuit R and 2R. So here we are using 4 R to R circuit here. So here we are using 2R. So R to R one combination, R to R another combination, R to R another combination. So totally there are 4 R to R combinations here. Here we are giving the inputs, digital inputs. So this is my LSB bit of my digital input, LSB bit, and this is my MSB bit of digital input D3. So D1, D0, D1, D2, D3. These are my 4 digital inputs. So here when I give input as 0, 0, 0, 0. So this 0 input I am giving it here. So this is my inverting amplifier using op-amp. So this inverting amplifier with a gain, I had taken a gain of RF, feedback resistor RF as 10 kilo ohm and RAS 16 kilo ohm. So here you can see the formula for output voltage. So this formula for output voltage, here you can see the non-inverting amplifier, gain of non-inverting amplifier. Here I am giving the input. So this is my input, I will take input as V1. So this V1 input is given to non-inverting terminal. So this one is my non-inverting amplifier with a gain of 1 plus RF divided by RA into the input voltage. What is my input voltage here? Reference voltage. So reference voltage divided by 16 into bracket 2 raised to 3 into D3 plus 2 raised to 2 into D2, 2 raised to 1 into D1 plus 2 raised to 0 into D0. So here we are giving the input. Suppose if I give the input as 0, 1, 1, 0, if my D3, D2, D1 and D0, suppose if it is 0, 1, 1, 0, 0 and D1 is 1 and D2 if I take it as 0 and 0. So 0, 1, 0, 0. In this way, suppose if I substitute these values D0 as 0, D1 as 1, D2 as 0 and D3 as 0. If I do the calculations here, my 1 plus RF, my feedback resistor is 10 kilo ohm, 10K divided by RA is 16K into bracket reference voltage. We are taking a reference voltage of 5 volt given. So it is 5 volt divided by 16 into bracket. So it is 2 raised to 3 means 8. So here D3 is 0. So D3 is 0 means this terms becomes 0. D2 is also 0. So this terms becomes 0. D1 is 1. So D1 is 1 means 1 into 2 raised to 1, that is 2. And D0 is 0. So this term is also 0 here. So if I calculate this for output voltage, I get V0. Theoretically, I get 1.625 into 5 divided by 16, I get 0.3125 multiplied by 2. So if I calculate this, I get output voltage to be 1.01. So this is my theoretical value. This is my theoretical value for the given digital input 0010, where D0 is my LSB and D3 is my MSB. So for this design, for the given input, we need to check for all the input combinations. For 4-bit, total input combinations will be 16. So here for starting from 0, 0, 0, 0 up to 1, 1, 1, 1 we need to take. I have taken one of the input here for calculation. So 0, 0, 1, 0. So we are doing it for 0, 0, 1, 0. For this combination, theoretical value we got it as 1.01. So it is 1.01, 1.01. So practically here I have done for the same circuit, here the correction is done in the breadboard. So here you can see the 741 IC. So this is my R to R ladder circuit So it is a 4 combinations of R to R circuit. So here you can see the digital inputs. So this is my D0, D1, D2 and D3. So my given input condition, if I take 0 0, so I will take 0 0 1 and 0. So 0 0 1 0. So this is my output. So this is my theoretical output. You can see 0.99. So for this 0.99, so this is my practical output 0.99. So we received 0.99. Suppose for another combination, if you do it for another combination of all ones, suppose if I take it for all ones, 1 1 1 1. For this, if I calculate, so these two terms will be constant. So 1.625 into 0.3125. So I will calculate it here. So for output 1.625 and 0.3125 multiplied by, so for my given input D0 is 1, D2 is 1, D1 is 1, D3 is 1. So all are 1 combinations here. So for 2 raised to 3 into D3 equals 1 plus 2 raised to 2 plus 2 raised to 1 plus 2 raised to 0. So if I calculate this, so we get the answer as 7.61. So output is 7.61. So what I will do, I will turn on all the inputs here, D0, D1, D2 and D3. So here you can see D0, D1, D2 and D3. So all are on here. So here you can see the output 7.81. So our theoretical answer was 7.61 and our practical we are getting analog output as 7.81. So we need to do 16 iterations for this, starting from 0 0 0 0 to 1 1 1 1. So I have shown it for 2 input combinations. You need to repeat it for all the input combinations. So here we are converting our digital inputs, D0, D1, D2, D3, these are digital inputs. I am converting to analog output.